Bode plot for the circuit shown for the gain, which equals basically a ratio of output voltage to the input voltage. Remember, output voltage is right here and you have the input voltage, is most nearly. So you have basically three plots over here that you see on your screen. We have to pick the right plot which basically justifies the characteristics of this circuit right here. So we have a system, and the fact this system is basically comprised of op-amp, and the negative terminal of the op-amp is connected to the source makes it an inverting amplifier. And we know from previous videos that the equation for the gain for inverting amplifier is just simply a ratio of R of F, which is a feedback resistor, divided by the source resistance. Now here feedback resistor is basically this capacitor right here, which means this has a capacitive reactance. Now capacitive reactance is expressed by X of C equals to 1 over j omega C. And the fact that we know that omega equals to 2 pi F makes it 1 over j omega 2 pi FC, correct? The source resistance is just simply going to be R, which is mentioned over here. Now gain equals to negative RF over RS. Therefore, the absolute value for the gain could be written as R of F, which is basically 1 over j omega C. So you got 1 over j omega C. RS is just simply R, so it just comes over here like this, and can also be written as G of omega equals to 1 over RC omega, right? RC omega. Now, if you notice over here that the relationship between the gain and that of frequency, remember that we are looking at the Bode plot. What exactly is a Bode plot? Now, in electrical engineering and control theory, a Bode plot is a graph of the frequency response of a system. So if you look at it in this graph that we have, the three of them, on the x-axis we have omega, which is basically frequency being increased. And as the frequency increases, the gain respond to that change in increase in frequency, correct? Now, and the fact that gain here is inversely proportional to frequency, which means if the omega increases, the gain is going to decrease because of the inverse relationship. And this characteristic is only found in this plot right here. When the frequency increases, the gain just simply decreases, right? So there is a straight line, which is not the case in this graph and also not in this graph. So this is a straight line in Bode plot terms, with the magnitude decreasing, magnitude of the gain decreasing as the frequency increases, correct? The 0 decibel point right here, which is referred to as a unity gain, it occurs when omega equals to omega of C, which is just simply equals to 1 over RC, correct? Now these characteristics are only present in this plot and not the other two, hence the right answer is this.